First, we'll start with the motors here. These wires are not very substantial going to the T-motor, but they are probably 16 gauge, give or take. So I went to my local electrical supply store and I got 12-3 stranded electrical cable. You'd find this in super heavy duty extension cords, for example, which is, I don't know if you can tell, quite a bit bigger in diameter than the original. So this will at least handle as much as these wires ever did. For the sake of quick disconnect for servicing and for changing rotation, you just swap two wires around. I'm going to solder on some 8mm bullets. So I guess it doesn't really matter which side goes where, but there is a male, those are male, and a female, and it has to be consistent. Since typically in batteries the female side goes on the side that's supplying the power, so you can't accidentally short it. Even though these are bare, I'm going to stick with that. So female side will go on the wire coming from the speed controller, and the male side will go on the motors. So these wires are actually pretty stiff and they're pre-tinned, so I'm going to add a little bit of my own solder to match. Probably get some vice grips to hold this guy as I soldered on there. Would it have made more sense to solder these on before mounting the motors? Absolutely. But hindsight is 20/20, and unfortunately, I wear glasses. Rinse and repeat. And of course, doing the same thing on the 12-3 wire, which is absolutely fascinating to watch, I'm sure, but just the female ends over here. Okay, on the harness side, I've got cable sticking out the side. That is because I figured this pocket is a really good place to store a battery. Super low-tech solution, I will admit, but actually really balanced. So I've already tried it with the pole, the boom, and the weights equal out. I'm not being tipped forward or backward at all, just adds pressure to my shoulder. But anyways, this is just some paracord, much like Justine did with her strapping that then attached to the bar for counterweight. Since I've got my mount set up so I don't need the counterweight, I'm able to put the batteries elsewhere, and honestly, I could nearly triple the size of battery in here. I can go quite a bit wider and maybe 2.5 times longer. But basically just these old carabiners that clip onto the webbing that pass through. It's super not tidy or anything, but as a Boy Scout, I trust my knots, and I've got 3 connections, so it's not going anywhere. But anyways, that will fit quite nicely in the back, and then I'll be able to run my power wire under my right arm and plug in. This is why it seems like I'm doing things out of order here. The battery pack placement actually determines how long my power cables for the speed controllers will be, which determines where I put the speed controller. So now that I know this works, I can measure out my speed controller wire, mount the speed controllers, or solder them at least, and get that rolling. So as seen in the previous video, got my APD 200F3 speed controllers. These are 200 amp, 14S capable. I'm running 12S, and each motor pulls about 120 amps, so this is way overkill, but I'd rather have it overkill than underkill. So mounting, I talked to APD actually and asked them where I should put it on this application. I told them I had a motor at the end of a effectively 4-foot stick, so half of it for just one speed controller. And I asked them, where should the speed controller go? Should I extend the power wire to the speed controller, or should I extend the wires from the speed controller to the motor? And they said power wire short as possible basically leads to less ripple and less strain on the capacitors of the speed controller. So that's what we're doing. I don't want to like burn or zap myself, so I'm mounting these outboard of the mounts. So we're talking right here, and that also gives us the length of motor wire we're going to actually need, which is about that much. And just outboard of the mounts also tells me how much power wire I'm going to need. So it's a little off. I don't see why it would make such a big difference. They said that these capacitors are super duty and should be able to handle pretty much any ripple. But since I'm running 14S capable speed controllers on 12S, that even lessens the effect. Anyways, the one thing I want to point out though is that the right side wires will be a little longer. So we're talking somewhere in the 3-foot range for the right side, and the left side, and the right side something more like 2 feet. So I don't see that a foot difference is going to hurt one speed controller over the other. I'll be able to feed signal to them all the same, but I just wanted to show where that was going. We'll do some wire cutting, some soldering. Yeah. So this is temporary, I promise, the tape. But the speed controllers are soldered and put in their places, and the wires are lengthened. So that's a 8-gauge OFC, just like my battery wire, and you'll notice they're in close proximity. Wow, look at that. Speed controller power's on, just as if I knew what I was doing. I might somehow attach this with a Velcro strap, but clutter-wise it doesn't seem so bad. So this is where it would be preparing to take off, and this is where it would be, you know, as I'm taking off, and then flying, of course, is really not much change. But battery length, battery placement in the back there is good, and we'll move on to making the netting. Okay, this is actually day 2, so it feels like I'm starting a new video, but I'm not. We're still rolling. Main spars behind me here. I've soldered the motor wire ends, and you'll notice there's no yellow tape on it anymore. There isn't, I promise. Switched over to zip ties, just tidying it up. Working on the controls now. This box is actually from my V2. There's an Arduino Mega 2560 in there, and you'll see it sports the open gauge moniker. If you don't know already, I actually developed the Open Gauge, an open source altimeter and GPS instrument for paragliding and ultralight pilots before ever starting on this paramotor stuff. So my Open Gauge V1 shows things like altitude, speed, heading, distance back to LZ, altitude above LZ, maximum flight altitude and speed, lots of other things. It's barometer based, so it's more accurate than just GPS, and it's a lot cheaper. It's just over $100 if you build it yourself, and it's open source, free to download. I'll drop a link in the description. It's open-gauge.com. It's where I'm also going to be posting this eventually when it's done, but that's just kind of my contribution. I feel like there are no good, cheap options for accurate instrumentation. Anyways, this box I've basically already designed for my version 2, which is in the works, but with a mount on the back to sling it onto a bar. I need to fix one wire for the screen. This is a 128 by 64 LCD, just like my Open Gauge V1, so visible in direct light or complete darkness because it's backlit. I've got a voltage meter here, a BMP 388 barometer, which is accurate to I think 1/4 of a meter. Very, very accurate. It's what they use in drones. These wires here will go to the speed controller, or speed controllers. One of them, I guess the right side one, since it's closer to the battery, will feed voltage through the white wire to power this thing, and this will send everything else out. And I've also got my controller, the handheld bit. I've already tested all of this, but it's a very simple design, just a potentiometer with a spring that returns it, straps onto your hand, typical paramotor stuff, and wire to connect into it, and then 2 holes to pass the wires through. So I'm going to be fixing this up and soldering on what I need, and we're going to keep moving with it and see if we can't get this thing up and running. All right, well, it turns out the BEC of the speed controllers isn't set up or something. I might have to add a new one, but they beep. I got the motors to kick. Hold on. Those are the motors making the sound for the speed controller, so they're connected at least. Okay. Well, that was exciting. Those were the motors spinning. Let's find out what we can do about that. Well, this is obviously Arduino programming problem. I don't have the right pulse width modulation set up, but that noise means that it's ready to run. So let me get the noise happening again. And they spin. It does, I swear. I can see it. The logo going around. Anyways, then it reinitializes every now and then, which isn't great. Yeah, there we go. Shouldn't be doing that, but step in the right direction. Both motors spinning. Arduino is at least attached to the bar. Needs some programming work. Alright, so that's it for today. Put together mostly. Next video we'll have this working, hopefully, and different propeller guards. I've already got that sorted out. Those are in the mail. But thanks for watching. Like, subscribe, all that junk. I listen to constructive criticism. Leave it in the comments. And we'll see you next time.